Okay, my name is Sachin. I work in Microsoft in Helsinki. Today I'm here to talk to you about service mesh. So, how many of you have heard about service mesh? Okay, let's start there. Okay, most of us. So if you have worked in Kubernetes, probably you must have heard about service mesh all the while in the last year. How many of you have actually used service mesh, like currently? A few, like less than what people know, but a few of them have used it. So a few months back, we used service mesh with one of our partners. It's a large bank in Turkey, and they were moving their monolith banking application to work on top of Kubernetes. And since there were a lot of microservices, we used service mesh. I'll come to the reasons why. So now service mesh itself is quite a large technology, complex. There are many different service meshes. So we only used a subset of those. So today I'm going to go through what we used. That does not mean that there are not other features. There are so many of them that I can't probably enumerate all of them. Especially something like Istio, which comes with loads of features. In this case, I'm going to talk specifically about Linkerd, which is a CNCF incubated service mesh. I'm biased a little bit towards Linkerd because I feel that it works out better than Istio does, at least out of the box. Linkerd is simpler, it has lesser features, but all the features which I'm going to show you were the ones which we wanted, so we tended to use Linkerd. All right, so let's see. That's a talk. So just bringing all of us on the same page as to what a service mesh is. Writing distributed systems, is hard. It's hard to write distributed systems because of the fallacies of distributed systems. And over time, as we started writing distributed applications, we figured that, well, there are so many problems that all of us have to then solve. Let's abstract it away. And that's how something like Kubernetes came up. Like, we are going to abstract away all the problems which software engineers need to face. We're going to move it one level above into a platform, and we're going to use some orchestrator to make sure that we don't have to deal with all of those problems. As you use Kubernetes and you use microservices, well, you don't even have to use Kubernetes. As you use some form of microservice architecture, some form of distributed systems, you will realize that the biggest fallacy of distributed system is that the network is reliable. Networks are not reliable. Things fail all the time. And in fact, going back to what's the definition of cloud native, in my opinion, it is expect failures. If your software works expecting failures, then I feel like you're cloud native, because we are going to work on unreliable networks, unreliable machines. Your software will go down, so can you make software which is resilient to those failures? In my opinion, that's what I call cloud native. So as we started to write distributed applications, even on top of Kubernetes and microservices, we realized that we need a better resiliency mechanism. We need something which will make sure that the services which we have now divided into many different, like we had a monolith before, now we have divided all that into multiple services. We need to make sure that the service can communicate with each other in a resilient manner. If something fails, we can gracefully degrade, we can retry, we can have timeouts. So what initially happened was that you must have heard something like Netflix OSS called Hystrix. So Hystrix is this library which lets you write resilient Java code on the JVM. So it provides things out of the box. So again, you don't have to make it, like retries and timeouts, what I was just talking about. And that works out pretty good. I mean, Hystrix is great. Then the question becomes, okay, what if you're not using JVM? Then what do you do? Well, of course, when there's good idea in one programming language, it always gets copied to another programming language. So eventually, people copied Hystrix all over the place. You have Go port for it. You even have Python ports for it. So yeah, I mean, if you write different languages, then you can just port one of those. So then the question becomes, okay, if my company is using in microservices, we tend to use like any language which your team feels is the right one for this purpose. So if we are going to adopt so many languages, are we going to adopt also so many different frameworks to make sure that the resiliency works out? Should we be solving these problems at our code level? Like, shouldn't we be dealing with business logic instead of network level concerns? So these were the kind of problems which eventually we started facing. We, as in community. So it's like, okay, we should abstract away all of these concerns, just like we abstracted away distributed systems concern into Kubernetes and figuring out the scheduler figures out where to put it. Maybe we should abstract away all of these network level concerns and put them somewhere else, so that we don't, like software engineers in our application code, are just concerned with business logic and not how to retry and how to make sure that things work in a resilient manner. So that's how service meshes were born. So service mesh is a network level software as an overlay over top of your application, which makes sure that your services can communicate with each other in a more resilient manner. That's the original reason why service mesh exists. And by doing that, by using something like that, you can consider the kind of intended consequence. It's not unintended. Intended consequence of service mesh is you get lots of stuff out of it for free. You have service mesh, you can use lots of stuff which you would then have had to do on your own, like some manual method. Two of the most important things which come to mind for most people is mutual TLS, which I'll show you like we used it, and network routing, like how you're going to route traffic within your cluster. So by using service mesh, you make it very easy to do MTLS and service routing, and the original reason for using service mesh itself, which is resiliency of communication between your services. So when we worked on the project with this bank, these were the features which we were mostly looking for. Now, if you go through Linked's documentation, you'll figure out there's loads of other features. So I'm not going to go through them. Maybe after this one, when we are having networking, maybe you can come and we can talk about it. Okay, so what is Linkerd? Linkerd is a service mesh, it's a CNCF project. It's in CNCF incubated. There are many different service meshes. I have used Istio and Linkerd. I've not used any other, but I'm sure they're similar in concept. So for example, HashiCorp's console comes to mind. Then, for example, AWS has its own service mesh on there. And there are loads of others like Mesh or something like that. Okay, so I had this talk in Helsinki once. So now how do you get Linkerd installed? Like, Linkerd is extremely easy to install even out of the box. It's like it comes with a nice command line tool. And you can just run it on to like Linkerd install and give it the link to your cluster, and it figures out, okay, what's on your cluster and what needs to be done, and it generates a YAML file, which you can then pipe to kubectl and just apply. So that works out of the box. Of course, you can customize it. If you were to go and work with, for example, your own certificate authority, you want to integrate your own certificates, or you want to use Helm, for example. In our case, we use this GitOps method, where what we do is, like, how many of you are aware what GitOps is? Okay, a few. So, okay, just going quickly. So instead of pushing the config using kubectl apply to the cluster, what we say is there is a component running in our cluster which looks at a Git repo, and any changes to that Git repo are automatically applied to the cluster. So nobody except the component running into the cluster has access to Git. Nobody has a write access directly using kubectl on a production environment. So you don't want to share this credentials just to prevent the attack vector or what's possible. If somebody has actually, it can get leaked and somebody can input something. So everything is audited in Git. You have to make sure that things end up in Git with whatever method you have, like a pull request. And once it does, the component will just sync its state and will apply everything. So as you know, Kubernetes definitions are written in a manifest. So that manifest is generally quite big. In our case, we use a component called Fabricate as a high-level definition language. I'll show you an example when I go to the demos part, in which you write very easily what all components you have, and then it gets translated to manifest. It's not very important for this one, but I'll show you like how the Linkerd manifest is there, and it's part of the definition. So a new cluster, when it comes up, so it just reads from that Git repo and reapplies everything. And in this case, we'll install Linkerd because it's part of the manifest. So by doing something like this, it's very easy to spin up new clusters. Again, I mean, you must have heard this, the thing in the Kubernetes community right now, just like do not depend on mono clusters. Do not depend on one cluster and it being like your sacred place. Clusters should be easily, you should be able to remake a cluster. It's just like pets and cattle, yeah, so just had a blank. So it's like pets and cattle. Your clusters should also be like cattle instead of pets. And so if it's something like that, just makes it very easy. You don't even have to deal with the Linkerd client. Everything is in the Git, so it gets applied. I'll show it to you what I mean. It's not very important from this one. So, okay, so Linkerd itself comes as a small portion, so it's not one monolith which is running into the cluster. It has multiple components. For example, it has tap, which looks at the network traffic. It has identity, which makes sure that you can get the certificates, and then that's how the mutual TLS happens. It has a service profile validator. Service profile is something I'll get to it soon. Anyways, I'll show you when I show you the Linkerd components. You'll see that it's divided into multiple components, and also you can run all of them in a high availability mode, which is then it runs multiple depending on the number of nodes. So of course, if you're in a production cluster, you run in a high availability mode to make sure that all of these components are replicated onto your cluster. Questions? Anybody has any questions till now? Okay, very clear. I'm not only deep, but I'm also clear. Okay. Okay, so how does Linkerd itself work? So Linkerd has this component running there. We're just talking about components, which is a controller which just is there to watch something like this. So when something gets applied to kubectl through the cluster or through your GitOps, anything which has, like a deployment, has this metadata annotation which says Linkerd IO inject enabled, will inform that component that, okay, this component seems like it wants to be meshed in. So it wants to be part of the network. So let's go ahead and add it to our mesh. So what that means is this is a sidecar. So your pods are, so the basic component in Kubernetes, as you know, is a pod. In this case, a Linkerd container is going to be part of your pod. So it's going to inject itself next to your container. Then it's going to run an init container, which will modify the IP tables of your container to route the traffic through Linkerd. So that's how Linkerd actually works. So it's quite transparent. You really don't have to do anything about it. All you have to do is apply this particular annotation to your deployment, to your pod, to your namespace, whatever requires meshing. And Linkerd will pick it up, and it will inject itself. It will modify the IP tables of your container and route everything through Linkerd. So that's the sidecar annotation. It's very transparent, works beautifully out of the box. And okay, so if you have something like that, you have a meshed network. So you have service mesh running in. So we're saying, like, just by doing that, like, just doesn't sound like Linkerd install kubectl apply -f. It should install all of the components. Things generally work out of the box. If your cluster is a bit special, you might have to do something, but more or less, it just works. Having done that, you get mutual TLS for free. Now, anybody who has implemented something like a credential system rotation would know how much work making sure your services can talk on top of TLS requires. You need to get certificates. You need to make sure that certificates are exchanged in some secure manner. You need to make sure that when the time comes, your certificates can be rotated. So there is a lot of work. You might have to install a certificate authority. Of course, Let's Encrypt makes it possible. The question is still, why do it? Like, why do it? So by providing something like this, makes it much easier. So there's this identity component running in Linkerd. When your service comes up and it says it wants to be injected, it talks to this identity component. It receives an identity. Every time a communication is going to happen through the destination component of Linkerd, it first checks the identity of the source and checks the identity of the destination to make sure that they are what they said they would be, and then the communication happens on top of an encrypted wire. So why do we do this? So in some industries, for example, banks in this case, you have a requirement that the data is not only encrypted on the disk, but it is encrypted on the wire forever. So you just cannot have plain text being going on. So for that reason, MTLS out of the box works out very nicely. So what we don't want is somebody having access to your cluster to inject a pod and then listen to the traffic of whatever is going on. Because lots of times what you have seen before traditionally would be your API gateway or your front-end gateway would terminate the TLS, and inside you are like, oh, now you're inside, you're free to do whatever you like, so you're just sending in plain text. And if somebody was to inject a pod in there, something, then you can listen to all the traffic, what's going on, which is what we are trying to prevent here. So in this case, mutual TLS, just because of an identity component, just works out of the box, so you don't have to do anything. Linkerd will upgrade all connections to TLS opportunistically, so if it can, it will. If it has injection, if the source and the destination both have the injection, then it will just be provided by Linkerd opportunistically. Like, you don't have to choose anything. You don't have to say, I want TLS. It's by default that it will be TLS. I mean, I think I've never tried to not have TLS, so I've never tried. Maybe I think it's possible that you can remove it, but I'll be like, why would you want to remove it? Like, when it is provided out of the box without you working. I'll show you what is the reason I'm not switching between the two screens is, it's such a pain to switch screens and then copy it and then go. So I'm going to show you all of this in one go. Okay, so this is the original reason why I was talking about service mesh, like reliable communication between your microservices. You have many different services. You want to make sure that one service can reliably talk to another, and if they can't, then they gracefully degrade. You can retry, and you can have timeouts. So this was the original reason. Linkerd has good support for it. So retries, very easy. You can read this. Just, again, some kind of Kubernetes spec where it says, for this particular route, this is the route which is which Linkerd can find out, because you're saying, okay, for this particular API/annotation, I want to say that it's retriable. So if somebody tries to hit this API and it fails for some reason, then retry it. Okay, so why don't we have retries out of the box? Because, as you know, not all calls should be retried. Not all calls are idempotent. So maybe we don't want to retry it. So that's why it doesn't come out of the box. Just like TLS comes out of the box, retries don't come out of the box. You have to actually write the service profile. So this is in Linkerd is called service profile. So for your service, you write some kind of profile which you tell Linkerd a little bit more about your service, and then you get these features from Linkerd. So in this case, as you can read, is if API annotation, somebody tries to get on it, and if it fails, retry it. So what you will see is Linkerd comes out with quite good metrics. I'll show you the dashboard soon. From there, you can figure out like what's the 4 golden metrics of my app. And in there, you can see that there is the success rate, which is the success rate taking consideration that it has been retried and how many times did it actually have to retry. So you can see both of them. So your client does not know that it got the response after a retry. So for it's successful, but Linkerd will note that it was a retry. So it will give you both the metrics as to what's the real rate of success and what's not. How many of them did require a retry. Wrongly implemented retries can have a serious repercussion on a distributed system. So what you can do is, you send a retry, it doesn't work. You send a retry again, and so it's called Retry Storm in distributed systems. So many systems are trying to retry, which leads to even more retries. So your system is becoming slow. That's why it's not able to perform. So you hit it with more retries, and it goes slower, and there's a whole degradation of the network. So to prevent these kind of things, you don't want to retry all the time. You can specify like, what's the retry budget? What's the ratio of the failure and the success I should keep track of? What's that ratio I must keep for my retry budget? So if it fills up this retry budget, then something is wrong with that service. So probably we should stop retrying it, because probably it's gone down or something is wrong with it, it's actually not working. So let's start retrying the system. So that you can control with retries budget. If any of you use Hystrix, all of this will sound like, okay, well, all of this is exactly like, so yeah. Instead of writing all of this in the part of your code, in your business logic, we have taken up one level up in a service mesh and provided to everybody out of the box, or by providing a service profile for your path instead of writing code for it. Questions? Okay. Another similar concept as timeouts. So you try to hit something. In a distributed system, the biggest problem is a failure is a good thing. Like, failure happened, nice. I know that something has failed. The problem comes out when the system just doesn't respond. And what do you do in that case? It's something like a timeout. Like, I don't want to keep waiting for it. I want so that there are no cascaded failures. So your service depends on some service, which depends on some service. So there might be blocking a path there and holding on to resources unnecessarily. So in this case, you specify like, oh, I want a timeout for my call. If it fails, just return an error status and don't wait for it. Again, out of the box, something like Hystrix, but in this case, in a different layer. The biggest reason, okay, mutual TLS could have implemented myself, could have used Hystrix, or in this case, we were using .NET, so there are other libraries in .NET which are ports of Hystrix. Could have done it. Didn't want to do Canaries on my own. So it's just like two big features of service meshes are Resiliency, which I just showed you, and network traffic routing. Like in this case, how do you split traffic between different places? Didn't want to do canaries on my own. Now, how many of you know what a canary is? What's a canary deployment? Awesome. So I don't have to go through explaining what a canary is. So you know, in Kubernetes we have a deployment. So deployment has a rollout strategy. You can set up max, upsurge, and how many minimum you want during a deployment. But it's still, after your all of your pods have come up, you shift the traffic there, and you hope that everything works out right. So that's the best we can do out of the box in Kubernetes. I mean, you just roll up a deployment, shift the traffic to the deployment, and hope that everything works out. In this case, couldn't do that. They're banking customers. Somebody's using your mobile phone to do something. You just can't go down. You know, like, okay, let's hope that everything works out. So in this case, what we're trying to do is canaries. Again, for the people who do not know canaries, it's like instead of shifting traffic all in one go, we're going to shift traffic in small batches, so 5, 10, 15, 20%. And if it works out well, we'll have some kind of test there. And if it works out well, we will shift all of the traffic there and remove the old one. So that's what canaries mean. Since many of you knew canaries, this is what it just explains that, okay, we start with 5%, we have 2 services. Over time, we move all the traffic to there, and then that's how we have canaries. So there's a similar concept like blue-green. In this case, you have 2 different ones, and you shift the traffic between the 2. In this, we have canaries, so you're shifting traffic slowly. All right, so some time back, Microsoft, along with other parties, came up with this thing called Service Mesh Interface, which is the description of vendor-agnostic service mesh spec. So Istio and Linkerd both support some of the SMI spec. In this case, there's something called a traffic split. A traffic split is a SMI spec which can describe how you want the incoming traffic or whatever traffic to be split into 2 different parts. In this case, says, okay, in this particular spec, I want the backends, my website v1 and my website v2 to have 50% of the traffic each. So this is what the traffic split looks like. So this is kind of what is just a representation of what I was just talking about. You can say 5 and 95, 10 and 90, and over time you can shift the traffic. So this is what we are using when we are doing canaries, so something like that. But in this case, it makes it even easier. So vworks, many of you must know what vworks is. It's a very popular company in Kubernetes. So vworks came out with Flagger, which is a component which is running inside your cluster, which automates this process of writing the traffic split. So I could have done kubectl apply, and in every step I could have done 5, 95, 10, 90, and so on. It just makes it automated. So there is nothing special. It just provides a CRD, a custom resource definition, which is in your cluster, which is called a canary. It makes it easy to say, okay, any spec which has a canary attached to it should go through Flagger, and Flagger will wait for your new deployment to come up, and then use traffic split spec to shift the traffic on your behalf with whatever percentage you want, like 5, 10, 15, 20, or whatever. So it's just an automated way for you to do it. So again, the concept is Service Mesh provides traffic routing. Provides traffic routing using traffic split, which is an SMI spec. Flagger is a component which is running in your cluster to automate this process by providing a CRD called Canaries. So again, by using Service Mesh and a few other components, it just makes it very easy for you to use something, quite an advanced deployment strategy like Canary, instead of rolling out everything on your own. All right, for the good part. Okay, quickly, let me first move this screen. I was just talking about, okay. The most difficult part is always moving a screen.
Isn't the Flagger having also like the logic of doing the shift, so if actually you have some degradation and you have some tests, checking that your new service is
very good point.
Problem,
yes,
that it doesn't actually go
absolutely. Yeah, absolutely, you're right. So I'll show you a spec and then I will show you a result. So first let me show you the result. So this is just of the logs from running a canary. In this case, you'll see, okay, some service has been updated. This service was annotated that it's a canary, so it requires a canary deployment. In this case, it says, okay, the canary were 10, 15, checking, 20, 25, or goes all the way to 50, shifted all traffic, everything works out fine. So this is how you will see it. Now, how does a spec look like? Let me move this one. Okay. Quickly showing you the spec. Okay. Hold on. It's a little bit difficult to Okay, I have this application here. And it has a Helm chart. And so something like that, it has a spec for it. So this should make it clearer. So in this one, there is a CRD installed by Flagger. So if some component has this kind of spec, then it should go through Canary. That's the point. So in this case, we define the spec as, for this particular deployment, this is the name of the deployment. What we want is to run this Canary analysis for 1/52, and max weight is this, and what we are actually doing is we want to, what we're doing is so we have this load tester running, and we are hitting a particular API, which we call automated test for Canaries. In this case, we are hitting the base, the root URL. And what we are saying is 99% threshold for 99% of the request, we want to measure the request success rate to make sure that all of them are 200. When we are hitting this one, we want to make 99% in the 1 minute interval. So in 1 minute interval, 99% of the request must return 200. And if the Canary, if your component is not acting correctly, there's some failure, of course, it depends on your test. Whatever test you write, in this case, this is just a demo test. Whatever case you has for your particular application, it will test your smoke test for your component. And if that fails, the Canary would be withdrawn. So it says not enough metrics or not successful metrics for request success rate detected in Linkerd's metrics. So going to roll back Canary, and it will not do anything. So it will remove all the traffic, and it will go back to the original deployment which was running. So that's how it would work. Does that make it clear? Okay. All right. So.
I have a question.
Yes.
Can you spin up like a new pod there instead of the? I mean, if you want to run like end-to-end test something, can you spin up like let's say a job there with all your tests?
Yeah. Okay. Let's see. So in this case, there is a load tester which is running. In this case, I am running this pod called load tester, which is acting as a load tester, which is running your this. So you can run anything you like, as long as in the spec you have to provide how to run your test. It doesn't matter what's the method of doing it. In this case, I have this pod, which is called load tester, which is just a front end to Hey. You can use any of the JMeter or whatever you use, some form of load testing system or some other system or testing system. And you should have access to your this. You should be able to hit that route. And as long as the Canary can access that particular pod, it should just work out. So yeah, you can spin up your own systems. In this case, I have this load tester because this came with demo, with the demo app. All right, quickly showing you, let's see, namespace, Linkerd. Oh, sorry, spelling mistake, Linkerd. Yeah, I was saying the Linkerd, unfortunately, it's a little bit off, so never mind. A few components like controller, destination, go ahead in the documentation, don't want to take too much time, but it itself comes with like a separate component. It's not running like a monolith as we would have not expected it to, like one single place where it fails. Okay, quickly I'll also show you a nice dashboard. Yeah, does it work? Oh, it is working, but not somewhere else. Sorry for that, I have no idea, that one. Okay, so it's like some dashboard where you can check different things about this. Again, I'm not going to go through it. It has these metrics I was talking about, the success rate. These are the 4 golden metrics for your particular application. In this case, it's the default namespace, which is this. It just shows you that there is a Ingress controller which is hitting some service. So it's just this one. So like it's just a demo route. So it just does that and that. Since I hit that, it shows this particular edge. And again, I think Istio has much better dashboard. But then if you're just going for the dashboard, then probably there's something else which we need to talk about. Linkerd edges. Just want to show you that there is mutual TLS between the two. Well, this doesn't prove anything, but maybe I can reduce the size. Sorry, it looks a little weird. Okay, can I? Sorry for that. Okay, yeah, fine. There you can see. Okay, it's just that I just showed you an edge. That the ingress controller has an edge to service. So if you hit the ingress controller, the traffic goes to service and it returns back. And in this case, this check mark just is to make you see that it is TLS. It's this one. Of course, the real demo would have been I go and do Wireshark and show you that all the transfer. I'm not going through that. Just trust me. There it is TLS. Well, try it on your own. It actually works out fine. Okay, so those are a few of the features which we used from Linkerd. As I said, Linkerd is quite a large component, come with lots of stuff. Just want to leave you, I've praised all of this for Linkerd, just want to leave you with a little caveat as to what went wrong with us. Just want to make sure that you understand it, that just like any component, this also has problems. One, it's a different layer, which means it's not like you have completely abstracted things away. People still have to understand it. And it requires maturity of your team to understand this kind of thing. So what I have noticed is junior developers or people who are new to Kubernetes probably will use it wrong. So you have to make sure that there is a certain level of maturity which your team requires to use something like service mesh. It's this complex component, one. Second, a component like service mesh requires, like your Kubernetes cluster or your microservice architecture, any distributed systems requires serious investment into monitoring, like your observability. And if you have not made that, well, then it's only a matter of time before the shit hits the fan, right? So, and especially if you introduce a component like Linkerd, you require serious amount of work to be done for observability. So quickly going through, we had a problem with a DNS onto the cluster. Because of that, the identity could not be found for Linkerd, and all of the cluster went off. All of the services were fine. All the code was fine. It was just that the identity, the access to identity was lost because of problems in the config of DNS servers, so ndots config on core DNS. And because of that, we couldn't find identity. And since we couldn't find identity, all the traffic was denied because it was considered nefarious traffic. It was not considered, we could not trust it. So all of the cluster went down. And we did not have good enough monitoring for Linkerd itself to figure that out in time. So the cluster went down. So again, it's a very powerful component, but with all power comes cliched responsibility, right? So you have to make sure that you have serious observability, and you have to make sure that your team is mature enough to absorb a component like service mesh. And that's all. Do you have any questions for me? There we go. Yes, Anton.
Good question.
Yeah.
How much, like, if you want to run Linkerd locally, this whole local testing, like you spin up K3s or kind, how much resources does it take out of the box?
Lesser than Istio.
Yeah, Istio is 12 gigs, I think.
Yeah, exactly.
So it hugs your computer.
So Linkerd version 2 was written, I can't vouch for like how many megabytes or something like that, but substantially lesser than Istio 1, and substantially faster than Linkerd version 1. Linkerd version 2 was written with Rust, has serious performance speed up, you can see. And in fact, I would say that the proxy is really low. All the components are plugins, so you have to install and use them. So if you're not going to use much, I think the current system is, the proxy itself is, it's very, very small. It's really small. It doesn't take much effects on the resources. But again, I can't vouch for it. You will have to do your own test. I'm sure if you're running like a large cluster with 1,000 nodes, for example, things will be different than just running on your machine. So it requires more work. I have not done that work, so I can't vouch for the numbers. Yeah. One more.
I'd like
yeah.
to just add that Flugger has pretty neat integration with Slack and
yes.
so you can
yes.
actually see the updates.
That's correct.
Happening from there straight.
That's correct. Yeah, and of course, Weaveworks has very good integration with Weave Cloud. And if, I was talking about GitOps, for example, and we use Flux in this case, which is also from Weaveworks, which you can send to Weave Cloud. We didn't use it because we were using the open source version, but they're quite well integrated if you go with that route. Any other question? Yes?
So how this works with WebSockets? Is there any problems on that?
I don't understand why, like, where do you see WebSockets, in fact, as the point? So this is service-to-service communication inside your cluster. So are you assuming that one service is talking to a cluster, talking to another service over a WebSocket?
Maybe just in like hypothetical.
Yeah. This is supposed to be for client response. So I don't think it's intended, like service mesh is not intended for WebSockets at all, because you're proxying through another place, so which means maintaining two connections, like long persistent connections. It's not how it's going to work out. I haven't tried it, and I don't think it's intended for that purpose. So no, this is for request response. Again, this is a very good point. It's also not intended for event-based systems. This is only for something like HTTP. So you're using REST, using gRPC or something like that. This is only intended for that. It's not intended. Lots of microservices system are based on events. So this is nothing to do with events. This is just for service-to-service communication, and not on WebSockets. I've not used it. Can't stand for it, but I don't think technically, if I think about it, it's going to work out. Because
it should work out.
It should work out, okay. Well, I haven't tried it. Also, you can, like, if you don't want some traffic to be routed through Linkerd, you can provide an annotation and say, okay, skip the traffic which is going to a particular port. For example, your MySQL or whatever database you're using port. So you don't want that to be routed through Linkerd. So you can skip all of that.
So if you don't provide an annotation itself, I guess then it skips.
Yes, it will route. So the IP table routes is for all the routes, all the ports, everything which is going out of your, would be routed through Linkerd. So you will have to actually provide, I don't want this to be routed through Linkerd, and then it will not be, yeah.
Maybe another thing also to add, like what you were saying regarding the service mesh, like what are the problems? Don't use it if you don't need it. It's like for the microservice.
Yeah, that's absolutely a very good point. So the reason, as I was saying, like could have done mutual TLS on my own, could have done service retries on my own, didn't want to do Canaries on my own. So that was the main reason we used it. If you don't have a reason, certainly don't use it. If your team doesn't have maturity, do not use it. It's a powerful component with a serious amount of investment required, but it has a use case. So if you do realize that you have a use case, I would go ahead and use it. But of course, like any good software, first you have to make sure that it's a component which you actually require. Yeah, please.
What is the cost of running it? Because TLS gives a little bit of an overhead, and as far as I know, I looked it up just right now, it's not using privileged mode, so it can't run in data plane mode. So it can't bypass the kernel.
Don't know what you...
Directly into user space.
Yeah, absolutely. So it's just running, so out of the box, it comes with its port security policies, which will only be applied if your cluster has PSP running. Otherwise, it just needs inet admin and a few of the policies to route the IP tables when it's starting the init container. It does not run in a privileged mode, and it will just route it through. So, but yeah, any MTLS system, it will have a performance impact because you're doing more stuff than you were doing before. But it will be exactly the same, or I think this will be better than you rolling out your own one, because I think this is more optimized. But it will certainly have an impact. So if you don't need it, don't do it. In this case, we needed it because it's a requirement of not to have any plain text communication over your cluster. So in this case, we do it ourselves, or we use something which comes out of the box. But there is a performance hit, absolutely, absolutely.
Would you opt out from the using MTLS?
I was just saying that. So Linkerd will opportunistically upgrade every traffic. I did not opt out, so I don't know. Most likely, yes. Must be some annotations there which says I don't want to do any TLS. I have not tried it, but I think it could be there. Yeah. Yeah.
Can you manage ingress and egress from the cluster with Linkerd?
Yes.
Or is only for internal?
No. As I was just showing you, the edge was between the ingress controller, in this case Nginx, and a service. So Nginx itself has been injected with Linkerd, so it is part of the mesh. In this case, yes, if you know that Nginx will not pass the source headers onwards after it terminates. In this case, you have to provide some annotation and ask Nginx to also provide the source. Otherwise, since it works on host-based routing, it needs the proper host name to route anywhere. So in this case, you have to provide certain specific annotations to Nginx to make sure that the whole mesh system would work. Otherwise, it will not work. You will have to do that. But it works fine for the ingress.
Can it also support egress?
Yeah, egress is something completely different. This communication is something which is coming into your cluster and part of your cluster. Egress policy should be maintained in its different system. So yeah, we can talk about it later, but that's not necessarily part of the service mesh. I think I'm going to stop now. If you don't have any questions, let's do it later. I want to take a break and give other people a chance to talk later. Yeah. Okay, but thank you very much. Yeah.